Hello everyone, welcome back to the Statistical Academy. My name is Sanjeev Reddy. We already have discussed about the data step processing in our class 3 video. You can find the link of that video in the description below. In this video, we will learn that process with examples and also we will learn how to control the data step processing and directing observations output. So are you ready to dive in and learn something new? Before we move further, don't forget to hit the subscribe button and leave a comment with your thoughts on the topic. Let us learn together. The links for the programs and the example datasets I use in this video can be found in the description below. The processing of data is in two steps: compilation phase, execution phase. Step 1. In this step, SAS scans each statement in the data step and checks syntax errors such as missing semicolons and invalid statements. In the step 2, the input buffer is created. Remember, if you read in a text or CSV file, then the input buffer is used to hold the raw data. If you read in a SAS dataset, the input buffer will not be created. Firstly, in the step 3, SAS creates a program data vector, which is a memory on your SAS Studio or SAS system. PDV contains the automatic variables underscore n underscore and underscore error underscore. The underscore n underscore equal to 1 indicates the first observation is being processed. Underscore n underscore equal to 2 indicates the second observation is being processed, and so on. The automatic variable underscore error underscore with the values either 1 or 0. If it is equal to 1, which means it signals the data error of the currently processed observation, such as reading the data with an incorrect data type. If you can see here in this program, I have assigned a value of character m for the numeric variable value. Let us run this and check the log. See the note invalid data for the value variable, and the underscore error underscore is 1 and the observation number that underscore n underscore is 3. SAS also adds a position to the program data vector for any variables that are created in the data step. See this program. The newly created BMI variable is derived by using weight and height variables. If any variable is specified in the drop statement, it will never be returned to the output dataset. At the end of the compilation phase, SAS makes the descriptor portion of the SAS dataset, which includes the dataset name, the number of observations, and the number of variables, names, and attributes of variables. The data step executes one for each observation in the input dataset. Suppose dataset consists of 500 records, SAS will execute 500 times. At the beginning of the execution phase, SAS sets all of the dataset variables in the program data vector to missing. Variables that you specify in a retain statement are not reset to missing values. The set statement reads the first observation from the input dataset and writes the values to the program data vector. Compute the first value for the derived variable BMI. At the end of the first iteration of the data step, the values in the program data vector are returned to the output dataset 2 as the first observation. The loop continues until all of the observations are read. The value of the automatic variable underscore n underscore is increased to 2. The values from the second observations are written to the program data vector, and it continues until all of the observations are read. We will see the execution in the log now. You can add put log statements at the strategic points in your code so you can examine the contents of the PDV during execution. The underscore all underscore keyword writes all variables in the PDV and their values to the log. And variable equal to enables you to write specific variables and their values to the log. You can also specify a message to write to the log. In this example, the ops equal to dataset option limits the number of observations that the set statement reads. So the data step only iterates thrice. After the set statement, SAS executes the put log statement and writes the message pdv after set statement to the log. Then put log underscore all underscore writes all the variables and the values in the pdv to the log. At the end of the 3 iterations of the data step, we can examine the log to see the pdv values for each of the 3 observations. We will check the log. We can see that the message we have specified in the put log statement is written here. Because of no errors at each observation, the underscore error underscore is 0. Underscore n underscore incremented by 1. Now you have a better idea of what happens with the pdv during the compilation and execution phases of data step processing. There are times when the default processing rules of execution are perfectly fine for your needs, but there are other times when you need to alter those rules to process your data in a different way. The data step enables you to control exactly how the steps of execution proceed. Let us start by looking at the implicit output that occurs at the end of the data step. By default, SAS reads one observation from the input dataset, manipulates the values, and writes the updated observation to the output dataset. But what if you want to control exactly when and where each observation is written? To illustrate this, let us look at the SAS help.shoes dataset. Each observation includes annual sales for region, product, and subsidiary. Suppose we want to create a new dataset that includes the sales forecast for each of the next 3 years, assuming sales increased by 10% annually. From what you know about data step processing, will this program write 3 observations for every 1 observation it reads? Let us try running this code. By default, SAS sequentially executes statements in the data step, and when it reaches the end of the data step, an implicit output statement writes the data in the pdv as an observation in the output dataset. Then the implicit return statement loops processing back to the top of the data step, and SAS goes through this process for the next observation. In this program, although the value of projected sales is calculated for year 1, 2 and 3, the implicit output only occurs once at the bottom of the loop. When SAS reaches the run statement, the values in the pdv are for year 3 and those values are written to the output dataset. We will run this program and see the result. We only have year 3 data. And if we check the log, we have 395 observations. You can use an explicit output statement in the data step to force SAS to write the contents of the pdv to the output dataset at specific points in the program. After assigning year equals 1 and projected sales calculation, I want this to be an observation. So I will keep an output statement, same way for the year 2 and 3. Let us run this program and check the log. There are 1185 observations. If I check the output, now the dataset has year 1, 2 and 3 sales forecast. You have seen that the output statement gives you the ability to control when to output, but one of the great features is that it also gives you the ability to control where to output. You can create multiple datasets simultaneously simply by listing more than one dataset on the data statement. Then you can use the output statement followed by the name of the dataset to which SAS should write the contents of the pdv. In this demo, we'll create multiple output datasets in a single data step. And we will use if-then-else logic in order to designate which observations should be written to which datasets. So in the data step that we are starting with, we are creating the heart2 dataset And you will notice that I do have some conditional logic to create the cohort variable. Depending on the treatment values, I wanted to create this variable named cohort and assign the value 1 if the treatments are drug A and B, 2 if the values are drug C and D, finally 3 with remaining values other than drug A, B, C and D. Well, I would like to go one step further. Besides just creating this cohort variable, I would like to create 3 different data sets for each cohort. So on the data statement, I am going to list the 3 data sets I wanted to create. Now I have those 3 data sets listed. I can use conditional output statements on the first if statement. I am going to modify this to make it if treatment values are drug A and B, then do after assigning 1 to the cohort. Then I will also use the output statement to write the data to the dataset named cohort 1. Now remember, if you use if then do, we have to close that block with end statement. And I will do the same thing for the cohort 2. Now you will notice the 2 statements that I have between then do and end. I did not indent. You don't have to indent. Spacing is certainly a personal preference. But one thing that is really handy when you use if then do logic is a format code button. If you click that button, it automatically spaces the program in a way that it is easy to read the different groups. Finally, I will complete the last else statement in order to create the cohort 3 dataset. So else do semicolon, I will put cohort 3 and end. So let's run this program and check out the 3 datasets. First, I will look at the log and verify that the 3 datasets cohort 1, cohort 2 and cohort 3 were all created in the corresponding number of observations. And then the output data tab, we are looking at cohort 1 right now, which looks good, and we can switch to any of other datasets here. Let's say that I don't want age at start in these 3 datasets. If I go back to the code, I will add a drop statement. When I run the program and look at the log, I only have 16 variables in each dataset. And if I look at the output data tab, datasets, you will notice that age at start has been dropped from all the 3 datasets. The ability that the data step provides to be able to read the data once and create multiple datasets is really a unique and powerful feature. In conclusion, this video has covered the topics including how to control the data step processing, viewing the execution in the log, sending output to multiple datasets. Thanks for watching. I hope you found this video helpful. Don't forget to like and subscribe for more. Until next time, happy learning.